Hello all, welcome to my channel. So today we will solve gate&ese 2011 question of digital electronics. So in the first question, the question asked you what is like the data has changed when the output Y in the circuit is 1. So this output is 1, and we know that this gate is AND gate, and AND gate has all that its output should be 1 when both inputs are 1. So this condition is satisfied, the output will be 1. It is only satisfied when the inputs to this gate will be 1. So this means that this Q has to be 1, and this Q is also 1, and we know that due to this is called as D flip flop, and due to the condition that D is always equal to Q, we know that whatever the data that we apply at this input is given as an output. This is the condition of D flip flop. So this is one. So what we can do, there are different options, like the data has changed from 0 to 1, or the data has changed from 1 to 0, or changed in either direction, that is from 1 to 0 or 0 to 1, or D option is not changed. So let us verify all these conditions. So condition number 1, when the data has changed from 0 to 1, suppose the data is 0 here, so the output is 0, right? And this is the complemented output, so it will be 1, and this 1 is given as an input to the second flip flop. Suppose this is A flip flop and this is B flip flop. So QA will be 0, QA bar will be 1. QA bar is given as an D input, and therefore QB will be 1, because here it is 1 and D is equal to Q, so it will be 1. But because this is 0, the output will be 0. And this is also a synchronous circuit because the clock is applied simultaneously, so that means both are working, both flip flops are working simultaneously. But what happened is, this flip flop only depends on the data. It is uh, working as whenever the data is changed from 0 to 1 or 1 to 0, the output is also changed. But this will be working because of the clock pulse. So when the data is changed from 0 to 1, this will be 1. So this will be 1, so the output will be 1. So this condition is satisfied. However, this will remain at 1 because this will not change until the application of the second clock pulse. Okay, so this option is correct. Now the second question is, the logic function implemented by the circuit below is, and in this question the ground which is shown in the circuit is implied as a logic 0. So this is a multiplexer circuit and we need to solve it. So because the ground is 0 and this is a NOT gate, so the output of NOT gate is 1. And what is again at I naught, because in 4 cross 1 there are 4 inputs, 2 selection lines, 1 output. So the complement of this NOT gate will be given as an output, so it will be 0. So I naught connected to 0, I1 will be connected to 1, I2 will be connected to 1, and this 0 implies, ground implies 0, so this 0 is given at I3. Now based on the combination of selection lines, so here are 2 selection lines, so there are possible 4 combinations, and on those possible combinations we get output, and output will be only 1. So what will be output F? It will be when PQ is 0 0, that is P bar Q bar then input I naught will be selected, so it will be multiplied by I naught, plus when PQ is 0 1, so that will be P bar Q, input I1 will be selected, so it will be I1, plus when input is 1 0, it will be PQ bar and input I2 is selected. Now the fourth term will be when this combination is 1 1, so when PQ is 1 1, input I3 will be selected. Put the value of I0, I1, I2, I3. What we get? We get P bar Q bar into 0 plus P bar Q into 1 plus PQ bar into 1 plus PQ into 0. So this will be 0, this will be 0. What we get as P bar Q plus PQ bar, and we know that it is equivalent to XOR. So P XOR Q. So in the given options, this will not be correct, this will not be correct, XNOR will also be not correct. So the output F will be equal to XOR of P and Q. If you like this video, please like, share and subscribe my channel. Thank you.